Right, 3 people in the beginning, in the front row. Very good. Now, I'm going to do my best to explain what's going to happen next, but I warned you, it's going to sound very awkward, but thankfully, specialists were going to come on this stage, and it's going to get much more entertaining after that. Our first speaker will talk mainly about Google Drive. I love that program. As a school teacher, very important, all parents leave their feedback there instead of the place they should. And we're going to find out about key web security concepts and how services can unintentionally interact. Now that sounds a lot like Estonian government. And how small flaws can be combined to break security boundaries. Back to the beginning. So, in order for us to kick off this event, please welcome on stage for some web security is fun or how I stole your Google Drive files, Lyra Rebane.
Okay. Hi, everyone. So today my talk will be about this vulnerability chain in Google services. But on the way, I hope to touch on some web security concepts as well. So hopefully you can take something cool away from it. I'm Lyra. You might know me from the internet as Rebane 2001. And I like to play around with the web and web browsers, and sometimes I also find vulnerabilities. And today I'm going to tell you the story of how I found this bug, but before I get to that, I'm quickly going to cover the topic of clickjacking. So clickjacking is this type of attack where you can take one web page and put it inside of another, and then trick someone into doing something. So, for example, if I want to give a talk at some cool event, I really want one of the organizers to click this little accept button beside my talk. How could I get them to do that? Well, what I can do is I can take this web page, put it inside of my own web page, and then just creatively cover parts of it up until it's turned into something completely different. Of course, I send it out then. The organizer sees this cool little cookie website, clicks the cookie, and of course, they're actually clicking the accept button for my talk. So that's basically what clickjacking is. It's something that has been possible since before I was even born. And it's something that every website is vulnerable to by default. But at the same time, because it is so old, it's very well known and very easy to mitigate. So in the past, we've used this X-frame options header, where you can do same origin to only allow framing on the same website, or you can block all framing altogether. And these days, you should instead use content security policy, which is more modern and offers some better security features and customization. But of course, this is a very old attack that's very well known and very frequently mitigated. So even with this example from the beginning, if I actually try to pull this off, you just see that error message. And that's because it uses one of those headers on the site. Let's take a look at another example. So for example, the Google Docs homepage. You can see in the network headers that it is in fact using the same X-frame options header with the same origin value. And we cannot frame the page. So far, so good. But something interesting happens once we try to frame a document. So, for example, if I put the presentation inside of an iframe on my own website, you can still see it, and you'll notice that it doesn't send the header. And the reason for that is that Google wants to let us embed these documents in our pages. And because they don't use the header, it makes them vulnerable to the clickjacking attacks we just discussed. So they found this middle ground where they allow framing, but they also detect it and thus disable some of the functionality. You can see the share button doesn't work, the Google Meet camera thing doesn't work. You open a menu, half the things there are grayed out. So that's how it works in Google Docs. OK, so that's clickjacking. Now let's get on to the actual story. So the story begins with me playing around in Google Docs one day, looking at the different features, seeing if there's anything interesting from a security perspective to them. And the feature I just so happened to try out is the feature where you can add a YouTube video to your slide. So you can add a YouTube video and play it. You can imagine there's a YouTube video. Oh, it is working too. OK. So you can play a YouTube video. How does that work? It uses the very same iframes we used in the clickjacking attack. So you can see it's doing this YouTube embed URL to put the thing on the page. And seeing that got me wondering, like, how is this embed URL generated? Like, can we replace it with something of our own? Because it would be really cool to be able to control an iframe inside of a presentation. So I pulled up my HTTP proxy. It's this program that lets you see the network requests for web stuff. And I found the specific request that added the video onto the page. And of course, it's a bit of a mess because it's Google Docs. It does some weird stuff. But something I noticed in the data is this part right here. So it seems like we're only giving Google Docs the ID of the video, which gets put in the embed URL. So we cannot control the entire embed URL. We can only control this video ID part. So can we still do something? Well, for anyone who's dealt with paths before, the first thought might be path traversal, which is this thing where you can have a folder. Well, in computer systems, if you have a folder that's just 2 dots, it's actually just referring to the parent folder. So it works on the web the same way. If you have a path that's 2 dots, for example, if we set the video ID to that, it should just go to the one folder up, so the home page. So does it work here? Let's try it out. I used my HTTP proxy to change the request. And I tried it out, and this is what I saw. So that is the YouTube homepage right there. Of course, YouTube also implements those clickjacking protections we talked about earlier. So we only see this error page. But this is already very interesting because we are getting out of the embed URL we're supposed to stay on. So are there any interesting pages that we could frame there? So of course, most pages have these clickjacking protections, like the home page, the video pages, and so on. The embed page we can put there, but that we already had before. And there are a few resources in the S path. There's like this error page, another error page. You can have sound effects, emojis, like source code and stuff. So it's very fun to put all these like weird things in Google Slides that are not supposed to be there. But from an attacker's perspective, it's still not very useful. It's just fun. What we really want to do here is somehow break out of like YouTube entirely. And what would be really good for that is something called an open redirect. So an open redirect is this like type of vulnerability where going to this one URL takes you to another one. And in most cases, this is not very useful. It doesn't really accomplish much. So oftentimes, it's not even considered to be an actual vulnerability. But in our case here, it would be really useful because we could get out of the YouTube domain onto some other pages to do some more interesting stuff. So I went looking for an open redirect. The first place to look on websites is looking at how external links work in like the descriptions and comments and stuff. So I took this link from the description. And in fact, it did work with the redirect. So that would be good, except for the fact that there's this signature token part thing in the URL. So unfortunately, that means that that redirect URL it goes through is tied to your current login session. So if you go to some other account, instead of getting the redirect directly, you will get this screen where you have to click through the Go to Site button, which is, it's kind of hard to convince people to do that. And even worse for us, that page with those buttons also has those clickjacking protections, so we cannot use that. OK, where else could we look for an open redirect? Maybe the login flow. A lot of pages, when you log into them, take you back to the same page you were on before logging in. And it's the same for YouTube. So if we go to this login page, we will get to this massive URL. And after we log in, we get to this another URL. And finally, we get to the page we were just on. So I'm interested in this URL in the middle here, because that seems interesting. So I cleaned it up a little, so it's easier to see. You can see we just have this thing, and we go to that URL, and we are redirected to the page we want to go to. So is that an open redirect? Let's try it with my own website. No, doesn't work. So maybe we can do some limited websites. Let's try Google's homepage. No, that doesn't work either. But at least earlier we saw that it did work with YouTube, right? No? So I was confused because these redirects did work earlier, but now they're all giving me these error pages. And then I realized that I had forgotten something here, which is the subdomain. After I added the subdomain back, it worked again. But that got me wondering, why would you have this entire long URL there instead of just a slash something? And it's I thought about it, and then I realized that YouTube actually has some other services too on other subdomains. For example, YouTube Music. So of course, I tried YouTube Music, and it worked. My next thought was can we use any subdomain? So I tried YouTube's admin page. That also worked. So looking at the attack surface right now, we started off with this embed thing. We did path traversal. We got access to all these paths. We did this other redirect. And now we have access to all the YouTube subdomains. So you can see how I've found all these little details, and one by one, I am slowly increasing my attack surface to more and more services. OK, so we now have all YouTube subdomains, but what can we do with those? Well, I couldn't find anything at first, but later on, I was just playing around with other Google services for fun and looking at how the authentication works on Google's website, not YouTube. But while logging in, I noticed in the network requests that for some reason, there was a network request being made to YouTube's website. Why is that? Well, Google wants to make it so that if you log into one Google domain, you get logged into every service you use. So every time you log in, it goes through every service, and for example, YouTube, and also puts your cookies there. So for that, it needs to redirect through all of them. And that just gave us this new redirect URL that we can play around with. So is this one an open redirect? No, it doesn't work with my own website. But does it work with google.com? Yes. So you can see how by chaining these redirects, we gain more and more attack surface. And of course, since we are inside of Google Slides, can we make it frame Google Docs? Yes, we can have an iframe of Google Docs inside of Google Docs. So you can see how the attack surface has been growing for us. Let's try it out for real. So I take this, make this video ID thing that combines all of these path traversals and redirects together into one. It goes through all the redirects, and we get Google Docs inside of Google Docs. So that's pretty fun. And it's very fun because you can put presentations recursively inside of each other. But what's interesting from a security perspective is that earlier we saw in the clickjacking example that due to this X-frame options header, we couldn't frame the Google Docs homepage. But in this case, we can. Why is that? Well, it's because our slide is on Google Docs. and our iframe is in Google Docs. So to the browser, that is the same origin. And because the xframe options is set to same origin, we can do this framing. So we can frame pages that were never intended to be framed and don't have those like protections that disable the share buttons and stuff. So what could we do? Well, we are in Google Slides. We can just be creative, cover it up with stuff, make people click like dangerous buttons or something. But looking around at this front page, what can we do on there? Well, unfortunately, there's not much we can do. The most dangerous thing we can do is we can delete someone's documents. But even that is like not that useful to an attacker and like requires you to click through a dialog and can be restored from the trash anyways. So we need to find something better here. So because we already have the Google Docs iframe inside of Google Docs, I just need to find something else on the Google Docs domain that could be of use. First, I looked on the Wayback Machine. So if you didn't know, you can put a domain in Wayback Machine and see every URL that has been archived there. So that's very useful for Recon, but here I didn't find anything. So I went on to Google to do like these Google Docs things where you like put all those keywords and trick things in the search and find stuff. And I started going through the links. This one was like some like open link that opens the file. But the problem is that if you visit that link, it redirects to Google Drive. So that's not useful for us. I took a look at the next one. It's like some Leaf one. That also goes to Google Drive. Took a look at some other one. This is like file view or something. That also went to Drive. I found some like folder format. That also went to Drive. So are we out of luck? Are all like these cool links being redirected to Drive? Well, no. I finally found one that doesn't redirect to Drive and stays on the Google Docs domain. And this was a really good find for us because this page is frameable for us because it's on the Docs website, and because it doesn't have the clickjacking protections the other pages do, it also has the share button available. So yeah, let's use it. Something I noticed really quickly is that if you have a Google Drive folder, you can take its ID, you can throw it in that URL we just found, and you can actually open up a Google Drive folder in the same view, still with the share button enabled and everything on the Google Docs domain. So OK, it's getting interesting. Let's try to put it inside of our slide and see what happens. So here you can see I made that like video ID that combines all the attacks we have so far. And when we launch it, you can see that it works. Oh, OK. So it doesn't work for some reason. OK, so yeah, I'm not sure what's up with that. Let's investigate with the dev tools. So I took the very same link I made that iframe with, throw it inside the page, and now it works. Why is that? So confused, I looked into the network requests, and then I noticed that the reason for that is that this is the request we send if I do the iframe thing manually with DevTools, and this is the request we send if we use the slide redirect thing. So the redirect causes this value here to go to cross-site, and that means that it won't work. So we need to bypass this, but like this is such a weird thing to like have in the first place. Why is that even a thing on the page? So I was confused, so I actually got the opportunity to talk to a couple security people from Google, and I asked them what's up with that. And I'm still not clear what threat scenario it's meant to address exactly, but it seems like it's meant for like scenarios where you have an iframe inside of a different page, and these are the headers you get. And you want to detect whether the iframe is inside a same origin page or a cross-origin page, and you can't like, and you can't do this check on the client side if you want to send out like server status codes. So these others are all you have to go off of. So just like a just weird sidetrack thing. Anyways, we need to bypass it. How do we do that? Here's the thing simplified. We can't redirect from YouTube to Google Docs because that causes that whatever mitigation thing to come up. But if instead just redirect from Google Docs to Google Docs, then that would work. So what we need here is like a redirect from our YouTube redirect to some like weird Google Docs page that then redirects us to the actual page we're after. And we need to find this part in the middle. So I went back to looking. I remembered from my like earlier searches that I kept seeing like these weird URLs with like government and like weird domains like that. And if you go on them, they just redirect you to the like, actual page that you were supposed to go to. So I'm not sure what that is exactly. It seems to be some sort of a, like Google G Suite SSO thing. Probably was very useful a long time ago, but right now it just disappears from the URL and does the redirect. So we don't really care about that. We just care about the fact that it lets us do this cool redirect that we are looking after. So that's perfect. We can now put it into our chain of stuff. And if we try it now, there we go. We can put the little like file page inside of a slideshow. And then we can start covering it up. We want to figure out what steps we want the target to take. And then we design the like things we're covering it up with in a way where we trick someone into doing something. So yeah, just 3 steps to win an iPad. I'm sure lots of people will fall for that. But there might be some people who are not quite convinced by this yet, especially because you need to type in a full email address into a very suspicious-looking text box. So we need to do better. OK, let's get back to work. So the current thing we have has 3 steps to it. We need 1 click, then like typing in an address, and then another click. Can we maybe somehow like skip any of these parts? I remembered that Google Drive has this thing where you can invite, or you can request access to files that other people have put links out for if you don't have access to them. So I looked at how that works. I sent myself a request, got this email with this button, tried the button, and yeah, it seems like promising. We have this dialog where instead of having to type in the full email address, we can just click the review button. And then after that, we just need to click the share button in this other dialog. So not an ideal attack yet, but we have skipped the hardest part, or like the worst part, which is the having to type in someone's email address. Now we just need to trick someone into making 2 clicks, first on the review and then on the share. So yeah, pretty OK. Can we actually use this in our thing, though? Because the other thing was like a Google Drive thing. This is the URL from the email. It seems like it has like parameters for the file ID, your email address, and the permissions and stuff. But it is on Google Drive. But because Google Drive and that like Google Docs page we found are so similar, can we maybe just take all these like parameters and stuff and throw them on the Google Docs URL instead? Maybe. Let's try it. And yes, it works. So yeah, that's cool. We can use this and do an attack with just 2 clicks. But can we do even better than that? Can we reduce it down to just 1 click? For that, we are going to have to do some reverse engineering and stuff. So I pulled up this page, and I opened up my dev tools, found where the code is located, set my breakpoints, and started debugging. So of course, with debugging the stuff, you want to start off simple. So I thought that maybe we can just start off with this URLs to invite parameter. I removed everything else, got the breakpoint, started looking through all the data and stuff, and stepping through code and so on. But then at one point, I just resumed execution. And what? That's like an entirely different dialogue from what we saw earlier. And it's like perfect for our use case. How did that happen? I didn't do anything, so I closed my DevTools, I refreshed the page, and it was still there. So the reason this is such a good dialogue to have, the reason this dialogue even appears in the first place is because I had changed the URL parameters by just leaving that one URL parameter in there. And that triggers like this different code path that gets us this cool dialogue. And the reason this dialogue is so good is because you can see it autofills the email address. It defaults us to the editor permissions. It sends the attacker notifications. And it has a one-click button to send out the changes. So that's perfect. We just need to trick someone into clicking this one button, and we can disguise it however we want. So let's create our attack for real this time. We start off with this iframe with the dialogue. We make up some like Google form or something. I don't know. We then just like creatively, cover up the pieces and stuff, make it look good. And then all we have to do is all we have to do is get the share link, change it to say present, and this is what it looks like. So you can send this to someone. Looks like a Google form, but of course, once they click on the send button, or they fill it in, they click on the send button disappears. So maybe they get suspicious when they see that, but by that time, I already have their files. So that's the vulnerability chain. Of course, I reported this entire thing to Google as well on the 1st of July. It's quite a lengthy report. They got back to me on the same day with the triage and confirmation. So that's really cool. And then they also gave me the bounty just 10 days later. So yay. And what did they give me? They gave me the maximum for the category, which is $3133.7, plus a $1,000 bonus for a total of $4133.7. And I just want to say I'm very happy with this bounty, even though on the exact same day, they announced that they are giving up 5 times more payouts in the future. OK, so before we get on to the questions, I just want to mention that I have written a blog post about this entire thing as well. So if you'd like to check it out in written form, you can find it on my website. My contact information is there as well. But yeah, questions? No, but you can find slideshows on the page if you look. They are like slowly patching out the steps. It's like not possible to do this attack anymore, but like some of the stuff is still open. I'm not sure. Yeah, they haven't fully mitigated this chain yet.
What do I do with this? Speak into it? Oh, OK. Is it like applicable to the real-life scenario? Because in order to actually deliver the attack, you need the file ID of the victim, and you have to know it, if I understood correctly? Or?
Yes, so you do need to find the file ID. But I've seen a lot of real-life scenarios where the file ID of a private document is shared in a way where you can see it. There's many ways to access that. So it is a hurdle. But it is definitely in the threat model of what Google thinks is the threat model. And
yeah. Thanks.
Yes.
They can throw a box at you. It's great. Or they can just give it to you. I mean, they're not going to throw it at you. You can still raise your hand. No hands. Cool.
OK. Yeah, in that case, thank you for coming to my talk this early, and hope you got something useful out of this.
Amazing. I don't know how to click, so I'm just going to give you a gift. Amazing. Oh, by the way, I was wondering, can we at some point get to the part where we don't have to click at all? That would be interesting.